Generating section views, created by Ahmed Damour. Welcome back. In our previous lessons, we created a complete 3D corridor using an alignment, profile, and assembly. Now, it's time to move from a 3D model to the cross-sectional view of our design. In this lesson, we will generate section views from these sample lines, visualize the roadway components, and analyze how our design interacts with existing ground. Before generating section views, make sure your drawing contains a sample line group linked to the corridor. The Create Multiple Section Views wizard in Civil 3D allows you to generate a full set of section views from existing sample lines. These section views visualize your corridor, surfaces, and material along the alignment. First, General page. First page, set the foundation for your section views. Here, you choose the alignment, sample line group, station range, and basic style. First, select alignment, from here, Rod B. Then, sample line group name. Select the group that contains your sample lines. Automatic uses the full station range of your sample line group from start to end, or user specified allows you to type a custom start and end station from here. And section view name, the wizard suggests a unique name which you can edit. It's best to use meaningful names like section views plus road name as shown here. Then section view layer, choose a dedicated layer like C road section view to keep drawing organized. And section view style controls how the grid, label, and lines appear. Choose road section. Then next, section placement. This page determines whether your section views are placed in model space for quick review or production sheet for final drawings. The first option, production. Select this when creating final printable section sheets. Choose a drawing template that contains section type viewport, and you can later use create section sheets command to place the views automatically into layout, or draft places all section view in a grid within model space, and here in a group plot style defines how the group layout and printable area appear in model space or sheet as shown in preview. Then click in next. Offset range page. Here you define how far to extend the section horizontally on each side of the alignment. Offset range automatic or user specified. Automatic read offset distances directly from the sample lines, and user specified lets you manually enter left and right distances. Then click next to elevation range. The elevation range page defines the vertical height and reference for each section view as automatic and user specified. In automatic, Civil 3D determines minimum and maximum elevation from all sections here, or you can check in user specified as 15-meter height, and in section views height option from lowest elevation for all section, bottom aligns to the lowest elevation found, or from main elevation for all section, centers vertically around the main elevation, or follow a section match the vertical alignment of a chosen reference section. But in longer alignments with major elevation changes, follow section helps keep each view visually balanced and readable. Then section display options. This page controls what surfaces, corridor components, or data appear in your section views. The list shows all data sources, existing ground and corridor B and surface corridor B. You can set, draw, check or uncheck to include or exclude a section. For example, uncheck in corridor surface here and select existing ground and corridor B. Then in column clip grid, trim the grid to match a selected section, keeping views TD. Then label set, choose how labels, stations, slopes, elevations appear, and style like existing and basic here. Override style. Check this to force a different style from the stored one here. Then click next. In data bands page, band sets shown above below each section. Select band set from here and choose which band set to use. Major station here. A band is the row or column of text adjacent to the section to show station, elevation, slope, and material. Then in list of bands, table that defines the band contain and position as location, bottom of section or top, choose bottom here. Then in set band properties, band type, section data, and style defines fonts and spacing. Then surface 1 and surface 2, choose which surfaces the band references, like corridor B or existing ground. For example, section data existing ground, e.g., choose surface as existing ground and surface 2 also existing ground. Then in finish ground elevation, choose corridor B surface as shown here. Also offset as corridor surface. Then create section views. And put it here. Zoom to section as shown. Civil 3D now generates individual section views for each sample line. Each section displays the corridor geometry, existing ground, and daylight connection as shown. For example, in section 100, this green label at the top is the section station. It tells you the station where the cross-section is taken along the alignment. And this green rectangle is the section view frame or printable area. And in vertical elevation axis here, these text and numerical labels on the right or left are the vertical elevation axis. They show elevation values for the section. And here, the white grid provides a visual reference for horizontal and vertical distance. Here, existing elevation in this row, and proposed elevation and offset. And here, this white line is the existing ground profile. It shows a survey terrain. Surface elevation are taken from this line and projected onto horizontal axis at the bottom of the section in existing elevation to giving us the natural elevations of the land as shown. And proposed elevations here are taken from cross-section of the road itself, where the existing ground line is above the proposed design. The area is cut or excavation, but here the proposed is above the existing, that's fill. For exact volumes, use analyze volumes and material to compute material. Thank you for watching. See you in next lesson.